those things at the same time, that does the multiple axes of freedom kind of capsule and a virtual system and the sustained G-forces. We do that.
And to whom did the Imagineers turn to provide the revolutionary technology that makes the experience of mission space feel so real that some guests wonder, have I truly blasted off from planet Earth? Hewlett-Packard.
Back in 1938, HP sold some of its first products to Disney for Fantasia to fine-tune the sound systems for the cinemas, and that really started the relationship between the two companies. And that's grown over the sort of 60-odd years in between, and Mission Space is a culmination of the relationship between the companies now.
Both groups are thinking out of the box. Both groups are trying to create very different ways to leverage technology in providing the experience that we're shooting for. And between Disney and the magic that they create on the side of it, where you actually touch and feel and experience the ride, and the magic that we can create behind the scenes that supports that experience, there's a perfect match.
It was very important for us to stick with our storyline. And the thing that was really fortunate about HP is they were a very good sponsor simply because they had a technology that was really applicable to our storyline and it actually could support our storyline. The fact that in the real world, HP computers are used in mission control. You know, NASA actually uses their hardware and their computers and whatnot. So it really was important that their product actually enhanced our story.
When we return, we'll join our recruits as they receive their training. Each will then be given a crew position with specific assignments. The success of the mission depends on how they carry out those assignments, especially when things get hairy.
To identify designers, engineers, architects, technicians, and others involved in creating Disney attractions, Walt Disney coined the term Imagineer.
While our recruits prepare, the crew here at the International Space Training Center will determine if they have the right stuff for launch. They will be introduced to the X-2 Deep Space Shuttle, which will take them on their unprecedented journey. But first, they will receive a briefing on astronaut training. The same kind of training that is going on at NASA today and has been an essential part of the program since its inception.
The training we went through varied as we went from Mercury to Gemini to Apollo. Initially in Mercury, we had some rather crude devices to practice flying the vehicle to the level where we in Apollo, we had simulators that were so perfect. Every window in the spacecraft had the actual view, day or night.
With the lower ejection handle, prepare to eject. Eject, eject, eject. Prepare to discover, give me a thumbs up.
Truthfully, the toughest thing for me about training was just the long hours. It's very, very intense, particularly the last 6 months before you fly. The wonderful thing is that you spend 10 to 12 hours a day with your crew, so you really become like a family. But the hard part is that everything else in your world kind of drops away.
The really cool part is getting to actually fly some of the training aircraft. We had a shuttle training airplane and T-38s where we met thousands of times, dove at the ground, simulating that final shuttle pull-out and touchdown.
All of the training is very demanding, again, from the flying to the academics to the simulators, the systems, you name it, it's very demanding, but it's fun and rewarding.
Those who are chosen to be astronauts go through years of rigorous training, and then once they are actually assigned to a mission, they train specifically for that mission for 12 to 18 months. It's only after years of training and preparation that they then get to fly.
When you're into training about 9 months to a year out, you are probably putting about 60-hour weeks, so it's very time-consuming. And there are just so many things to learn. We always make a joke that there's always 1,000,001 things to learn, and it's always the 1,000,001 thing that just tosses you over the edge, and you can never remember that last thing.
Each spacesuit weighs about 350 pounds, and that goes for the ones that we practice with in the water. So you've got 350 pounds of spacesuit on your body. It's so heavy, as a matter of fact, that it's mounted, the suit is mounted on a stand. You don the suit, and they pick the stand up with a crane, move you over the water, and lower you into the water. Divers detach you from the crane and swim you down to where you need to go in that suit. 350 pounds, so you can't swim in it. It's very big and bulky, it resists your movement. So physically speaking, that's the most difficult part of the training.
To ensure the authenticity of mission space, the team of Imagineers spent years consulting with NASA advisors, astronauts, and rocket scientists from the Jet Propulsion Laboratory in California. They even trained at astronaut facilities throughout the United States.
Part of the, making of the magic was going through all of the process, seeing what the astronauts go through, playing with their tools, seeing what type of instruction they do, to sort of narrow it down to what the best experience would be for our guests. So part of making the magic was, for a small portion of my life, was getting to be an astronaut.
We got to go to Johnson Space Center, and we got to talk to astronauts. We got to fly in the shuttle simulator. And I think the coolest thing about that is, here you are in a trainer that every single astronaut that's ever been into space on the shuttle has actually been and trained in. And you actually have the opportunity to be in this same vehicle. I mean, those types of things are just, phenomenal. You can't even dream those things.
For me, the added layer was to look at pictures on the wall there of astronauts that had trained there, and to realize that, geez, this is where John Glenn was. Those people, and so it was a humbling experience for me.
Here at Mission Space, our recruits are given an assignment. Each assignment comes with a responsibility, and each crew member will have to execute their orders flawlessly in order for their mission to be successful.
NASA is famous for teamwork, and for a very good reason. We're in a situation where every single player, from the person who turns the wrench to make sure that each and every bolt is tightened on the shuttle, to mission control, to the astronaut corps, everybody plays their own part in mission success, and there are lives at stake, and also a tremendous amount of expensive hardware, national prestige and honor, and of course science.
One day you find out that you're assigned to a mission. The boss calls in, tells you, and so you find out who the other members of the team are. It can be in a space shuttle. It started out with a couple of people and ranged up finally to teams of 7, in one case 8. Well, when you find out who else is on the team, if you're the commander, you look at the skills of everybody on the team, what you have to do, and you organize.
It takes from 2 to 3 years to really be ready. That's when the crew is named and they start working together, because they're not doing some sort of canned routine. They're building the flight plan from scratch.
Our crew has entered the ready room and is about to receive their assignments: pilot, commander, navigator, and engineer.
Pilot, responsible for getting the X-2 rocket safely from Earth orbit to its destination in deep space. Commander, responsible for directing the deep space mission aboard the X-2. Engineer, responsible for operating the ship's systems, including activating hypersleep. Navigator, responsible for tracking the trajectory and initiating major changes in flight path.
We are about to push the envelope here at Mission Space. When we come back, go for launch.
Mission Space contains many artifacts that help tell its story, including a scaled-down replica gravity wheel that creates false gravity through spinning.
For centuries, humankind has gazed into the night sky, to the stars and planets above, and thought about what it would be like to go to those faraway places and who might be there to greet us. All of us have wondered at one time or another, is anyone out there?
During the 19th century, Mars was more and more regarded as the planet most likely to harbor life. People began to speculate about life on other worlds.
Oh, goodness gracious. You sort of look at Star Wars, and you look at aliens, and you look at, all kinds of creatures with large eyes and large heads with big brains. That's sort of what I always thought Martians would look like.
Well, as a kid, I went to the Saturday afternoon matinees, and I saw Flash Gordon landing on the moon or Mars or someplace. So science fiction is a precursor to what eventually happens oftentimes.
But they were the typical giant heads, giant ears, big veins that pulsed, and little bitty bodies.
H.G. Wells excited countless imaginations with his approach to life on Mars. He describes an invasion of the Earth by octopus-like creatures. With their heat rays and poisonous gases, they are quite invincible. until they encounter the common germs in our atmosphere.
Since I was a kid, I have hoped that there would be life on another planet. I have always thought that it's very likely that there's life out there. I have not really thought that there were Martians, per se, in our solar system, but I'm hopeful. I'm very, very hopeful.
Mission Space catapults us to the year 2036. And where will space travel take us then? Mars, the red planet. It's always been a mystery and a fascination, and the allure of Mars is as strong as ever because now, actually going there has never seemed more possible. At the end of the last millennium, NASA was preparing itself, and the rest of the world, for the boldest Mars mission yet, to send twin robot field geologists, Spirit and Opportunity, to explore and study the red planet.
From the go-ahead on the budget to the landed operations was 3 years. That's about 36 months. Normally it takes about 90 months to do that part of a project life cycle. And the team has risen to that sort of challenge to a phenomenal degree.
I had to think about that for all of a millisecond and said, yes, I would. I'd love to drive a Mars rover. So we got to write some software to help drive the rovers, and then we're using that software to drive the rovers every day on Mars.
We have an assembly, test, and launch operations team which builds and tests all of the hardware, so all of the actual spacecraft to put together. That team worked round the clock for a number of years, in fact, to put the spacecraft together.
This launch was special. I had much more of a connection to this one. This one was carrying kind of part of me with it. It was going to give me an opportunity to do something I'd wanted to do since I was a kid.
3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
To sit through the 6 minutes of terror, as we describe it, from when the spacecraft hits the top of the atmosphere going 12,000 miles per hour and has to get down to 0 miles per hour 6 minutes later.
If the rover doesn't survive that, then everything you've been working for all that time was kind of, in one sense, was for nothing.
I was in this very room, surrounded by the science team. The whole team was watching the control center and sort of listening and on tenterhooks.
But really everything you can do has been done up to that time. There's nothing you can do but just kind of, be anxious and kind of stare at the clock.
My heart into this vehicle, and I absolutely was so excited and so scared that it wasn't going to work properly, and yet it did. It worked great.
We get that first confirmation back that things are working, people just kind of, people jump for joy literally every time.
And then we went around and hugged and kissed all these different people that I don't even know necessarily who they all were.
Pat each other on the back, and you did a great job with the pyro system. Congratulations on that.
We didn't expect to hear from each of the spacecraft, and every time we thought, well, maybe we'll hear, maybe we won't, and we heard. And then we thought, well, maybe we'll get a little data, and we got a whole lot of data. And every single time something was supposed to happen, that it might not work, and we were sort of hedging our bets, it always worked.
The mission set new standards for planetary exploration and caused Mars to give up some long-held secrets.
So the first picture we got back was Spirit kind of looking down at her own chest and beyond.